Now, I know 3D printing isn't as novel as it was maybe 10, 15 years ago. I mean, even some of my friends who have no interest in design have them, but I still think 3D printing, especially one of these resin printers, it's one of the most impressive pieces of tech that I own, at least in my opinion. I mean, being able to shoot light at resin, cure it, and then stack it up to make usable 3D prints with incredibly high resolution is one of the most impressive things that I can do. And as well as that, this whole thing only costs about $400. And at least in some situations, it's the better choice for making parts because you can do overhangs and internal details that you couldn't do on even a 5-axis milling machine. But at least for me, it's never been much of a hobby for me. I know some people do like them, but for me, it's more of a set it and forget it sort of thing. And at least to me, that's not a whole lot of fun. And I also think there's an element of, if the machine that you're using isn't actively trying to kill you, the hobby generally isn't going to be as fun. I should know. And that's why for the most part, it's remained more of a prototype machine, although there are reasons why I would use it. For instance, I don't have a 5-axis CNC machine, so for parts that have a lot of detail that would need to be made on a 5-axis mill, I do use this. And there are other parts where, I could make it on my lathe or my mill, but it's more efficient and a better use of time or materials to make it on a 3D printer. Let's take this part for example. It's a relatively simple adapter that connects the back of the orbital sander to the shop vac. For whatever reason, even though the shop vac and the orbital sander are made by the same company, you can't actually attach them together. So what I did was I went ahead and made a simple adapter that connects the two together. And whilst I could make that on the lathe quite easily, it would be a pretty inefficient use of materials. I mean, I'd have to take it to the right size, bore out the center, then take it to the milling machine, attach the dividing head to make the slot. It's only about a 10-15 minute job, but it is a big waste of materials. Plus, I don't have the lathe or the milling machine here, so the other big advantage is I'm able to make this at night in the span of a few hours in my living room. It's just unfortunate though that this part failed in the 3D printer, which I guess is the other good part, because when things go wrong, you can blame the machine. At least I certainly do. Although just having the 3D printer isn't everything, because you can't just go online and grab an adapter to an Azito orbital sander to an Azito shop vac. These things just don't exist. And that's what I want to talk about in this video, because I had to design this from scratch in CAD. And every time I bring up CAD on the channel, I do get quite a few people asking me sort of what is it, what software do I use? So that's what I want to go over in this video. Now the first thing I want to point out, because I think it's sort of important to make the distinction, is that 3D modeling isn't the same as CAD. And I think that's a pretty common mistake to make. And I see a lot of people asking, well, what software do I use for 3D modeling? Or what exactly am I doing when I 3D model something on the computer? Because really what I'm doing is CAD, or computer-aided design. And on the surface, there is a lot of overlap, and in fact, the softwares do look almost the same. The big difference is sort of the intent of the software and the people who use them, and I guess for what you're using them for. Alright, fingers crossed that's legible. So like I was saying before, 3D modeling and CAD have a big crossover because you're going to be making, 3D models on the computer. And in a lot of situations, it probably doesn't matter a whole lot what sort of software you use to make some parts, especially low tolerance 3D printed models. I've used both, and as long as you get the scaling right in the slicer, when you import the STL model, it really doesn't matter a whole lot. But once you really dig into the software, you'll find that 3D modeling is mainly geared towards VFX, gaming, and animation work because it prioritizes speed and freeform modeling over dimensional accuracy. I mean, as an example, let's say I needed to model this chair on the computer for some animation work. Well, your best bet would be to use 3D modeling software. I mean, you could make it in CAD, but it would take a long time, and unless you're really aiming to get millimeter accurate detail, you wouldn't do that. There's also a lot of curved features, and whilst you can make that in CAD, it takes you a lot longer. So doing this in 3D modeling would be the obvious choice. However, when it comes time to actually making a product, a product that you need to test and then manufacture and then possibly assemble on the computer to make sure that everything actually fits, you always want to go with CAD. And that's why engineers, designers, product designers, they all learn some form of CAD. And I'd say the biggest reason for the difference between the two ways of designing things is the underpinnings, because with 3D modeling, the normal way of making stuff is via something called direct 3D modeling. Whereas with CAD, generally speaking, most of them are going to be something that's called parametric. And I think it might be a bit easier to go ahead and just show you the difference. So on my left-hand side, I have Blender open, which is an open source 3D modeling software, but you'd be surprised just how often it crops up in actual VFX work. And on the right, I have Solidworks, which is a CAD system, and it's probably the most common CAD system in the world. Now, I don't want to spend too much time going over 3D modeling, but I think it is worth at least delving a little bit into it. So Blender's strength is that you can very quickly model parts, and the parts don't need exact dimensions in order to work. For example, with the cone, I'm able to eyeball its height and its diameter, and the same thing goes for when I'm adding the chamfers. It doesn't have to be hugely precise, especially if it's going in the background of a shot where the exact size doesn't exactly matter. And the reason why the dimensions aren't as important as compared to, say, visual accuracy is because the 3D models are simply points in space which are joined together by polygons to make that 3D shape effect. Where those points are in space effectively will define the shape. And what that means is you can simply pull on faces, points, and lines to change the shape of the model. The thing that I really like though are the virtual sculpting tools, so you can very easily make free-form and organically shaped objects. Yes, you could make something like that in Solidworks, but it would take a lot more effort. And modeling is just one small part of using Blender. The main thing that I've used it for is for rendering, and when it comes to that, it is a real beast for rendering, especially considering that it's free open source software. And before we move on, I do want to stress that even though that the parts that are designed in 3D modeling software, they're not going to be as pinpoint accurate as something like CAD, it doesn't mean that the software is any worse or any better. It just means that they're designed for different applications. And it doesn't mean that the people who use this software are any worse or any better. It's just that we're doing things for different reasons. And in fact, something like this T-Rex, this is designed and rigged in Autodesk Mudbox, and something like this probably impresses me more than about 90% of the mechanical parts that I see. So let's finally jump into Solidworks. This is the 3D CAD software that I use, and it's probably the most known, or at least the most used CAD software in use today. And in my opinion, it's probably the best all-round CAD package that you can buy. Although I'm probably a bit biased because I have been using it for about 12 years now, so the only way that I'm going to switch is if you try and pry it from my cold dead hand. Although with that said, given how many companies do use it, both small and large, it must be doing something right. And in my opinion, that's it being relatively easy to learn and use. It has very good modeling tools, and it has relatively powerful simulation tools. And effectively, you can use this one piece of software to design products from the ground up. You're not going to be able to make an engine or a car in this piece of software. It's not powerful enough to do that. But for most product design and engineering teams, this is usually the go-to software. With all that said, Solidworks is not the end-all and be-all when it comes to 3D CAD. Just as a bit of a comparison, this software here is CATIA. If you're not familiar with it, this is sort of the step up from Solidworks. It's made by the same company, and it's not so much a CAD software, it's more computer-aided engineering. It is a lot more powerful than Solidworks. You can do much more advanced surfacing, and it can handle part files where you have literal thousands of individual parts that make up large assemblies. While something like Solidworks, that can struggle once you get past a few hundred. This is the same software that Boeing used when they developed their aircraft, and I believe BMW also use it when they develop cars, and most of the Formula One teams use this software. The problem most people run into, me included, is it's such an unforgiving program to use, and you do have to do a special course on just learning the basics. With Solidworks to a large extent, you can sort of learn it yourself. And that's why you don't see a lot of people on YouTube use this software. Although it probably has something to do with the license for this costing about $15,000. Now, what most people actually use, at least on YouTube and in hobby circles, is Autodesk Fusion 360. It's free for personal use, and I think it's about $1,000 a year for business use, which is really good for a proper CAD software. It's not as powerful as Solidworks, it definitely doesn't handle large assemblies as well, and I'm not too sure if you can write scripts for it, but for most hobbyists, this is a perfectly capable piece of software, and in fact, I know quite a few startup companies that are starting off with this software. It's also relatively easy to learn, so that's why I recommend that people who own, say, a CNC or a 3D printer go ahead and at least learn the basics, just so you can make very basic parts if you need to, basic parts that may not be available on Thingiverse, and you might need to go ahead and make it yourself. Which brings me back to Solidworks, and I think the easiest way to show you it is just to run you through the basics, because on face value, it's not a particularly complicated piece of software if you want to make very basic parts. Now, each part will start off as a sketch in 2D. That's effectively the shape that we want to make and pull it into 3D. So if we want to make a very basic cylinder that faces up, or simply make a 2D sketch of a circle on the ZX plane, that's the top facing one, I can then assign it a discrete diameter, say 10 millimeters, and then we can extend it to make it a 3D shape. And let's make it 50 millimeters tall. And there's our cylinder. And instead of being made up of polygons, as it would be in something like Blender, Solidworks has it exist as a 10mm diameter, 15mm tall cylinder. Now, for instance, if we want to add, say, a square hole all the way through the center, we can simply make a new sketch on the top surface, make a sketch of the square that we want, give it a specified length value, and then we can tell Solidworks to remove that material. We can also round off the top edge by using the fillet tool and giving it that nice curve, and we could also give the hole a slight taper by using the taper tool. And that's our very basic part. And you'd be really surprised with just how many parts and objects can be made with these few basic commands. I think 90% of what I do when I'm designing are just extrudes, cut extrudes, fillets, and tapers. And for the most part, I don't think you want to overcomplicate things unless you really have to. Should be noted, this is not the only way to use Solidworks, but in my opinion, it's the most straightforward and probably the easiest to learn. And the funny thing is, because CAD leans more towards this sort of flat geometric design rather than the more sort of organic shape, you'll quickly see when you look at design products, just so many parts, or at least parts of products, are just simple 2D extruded shapes with basic curves and fillets. I'm not saying for 1 second that it's not easy to do curves, but it's definitely easier not to. But the big thing that makes Solidworks and most CAD packages special, or at least very different to 3D modeling, is that they're parametric. Not all of them are, I know Rhino CAD certainly isn't, but most of the big ones certainly are. And parametric effectively describes how the program builds, stores, and reads the 3D designs. So to hopefully demonstrate the sort of underpinnings of CAD, I'm going to do a bit of an analogy with some post-it notes. And the post-it notes are sort of representing the features of a part. So let's say, for example, we're making a part, and the first bit of it is this blue post-it note. This is going to be sort of the origin, or something that everything else is going to be based on. So let's say next to it, we'll add a pink post-it note. Now let's just say the pink post-it note is referenced as being right next to the blue one. And then, as our third part of the design, we'll then add a green one. And we're going to define the green part, or this third part, as being right next to the pink, which is also right next to the blue. Now, because parametric CAD or design sort of treats all of these as separate things, what we are able to do is tell the design software, instead of being a full-length post-it note, let's go in and switch it out for something that's maybe half the size. And what it's able to do is simply update the model like that. And it's able to do that because each part is treated independently. In a similar manner, we can easily make this, say, half as big as it was originally. And as long as this corner is still here, it's able to say that this post-it note is right next to this part, and this part is right next to this part here. However, what Parametric CAD isn't able to do is simply for us to remove this post-it note here. Because the problem is now we have our origin or our original piece and we have our other piece, but this piece here is defined as being right next to the pink post-it note. And as you can see, the pink post-it note no longer exists. So we're effectively trying to define it as being next to a part that doesn't exist anymore. The part effectively breaks. Now what we can instead do is simply tell it to either exist as being right next to the blue post-it note, which is perfectly fine, or we can say this green post-it note exists X distance away from this post-it note, and that would work just fine. So to show you exactly what I mean, what I have here is a model of the bottom half of the boring head. I have one model in Blender and one model in Solidworks. At the moment, they're exactly the same, both dimensional and shape-wise, so if I was to go ahead and 3D print both models, they would come out being exactly the same. But the thing is, Blender only sees this model as polygons in space. I can't, for instance, go in and change some of the older dimensions to update the model. But Solidworks, on the other hand, use it very differently. For instance, you can see all the parts and features that make up the boring head in the so-called design tree on the left. It effectively details from the beginning how I went in and designed it all. And it tells Solidworks how to read and make the part. To Solidworks, it doesn't see this as a boring head, but it sees it as a set of incremental steps. So to Solidworks, this part is a 2D sketch which is extruded on the XZ plane to form the body. A sketch is then drawn on the right plane and then dimensioned and then mirrored and cut away to form the profile. The dovetail sketch is also drawn, dimensioned and then cut out. The cutout for the screw and dial is also made the same way, as is the holes for the tool holder. And Solidworks effectively takes those steps and it builds the 3D model. The beauty of doing it this way is twofold. One is that the dimensions and the part relationships are baked into the design file. So what that effectively means is I should be able to open this design file in any other parametric design software and the shape and the dimensions should be preserved. That effectively means if I send this part off to a manufacturer, they should be able to open this with their own software and the part shouldn't change size, which means they can then go ahead, manufacture it, and I should be able to get a part back that is the same as the one that I sent. Compare this to something like an STL file. Sometimes you try and import it and the scale will be incredibly off, and if you're trying to send this off to a manufacturer, that can cause issues. The other cool thing about Parametric CAD is that because the software sees parts as a series of steps when building it, you can effectively go back and as long as everything is properly defined, you can, within reason, go and change the sizes or positioning of features and the part will simply update and adjust to its new size. For instance, maybe I'm using slightly smaller boring bars than I was previously. I can simply go into the computer, tell it to make the holes slightly smaller, and the computer will update the model like the holes were always that size. And doing it that way is so much faster than having to go in and directly remodeling the part. We could also make the diameter of the stock larger, and if everything is done correctly, it won't break the model. This, however, is a bit of a two-way street because it's important to remember that because we have this part relationship, it means we can't simply delete some parts if other things are defined off it. For example, let's take the outside cutout. We can't simply delete it because the inside cutout is referenced off it. What that means is when I was designing it, I told the computer that the inside cut is X diameter, it's 3mm wide, and it's made 3mm offset that back face. So every time the computer loads, it remembers that instruction. But if we go ahead and delete that face, the computer now has no clue where to put it because the face that we referenced it off no longer exists. Now the thing is, Solidworks, thankfully is smarter than that. I can go ahead and tell it to ignore the error, and I am able to carry on. And I've been able to save parts that have errors before, but the problem is when you give the part to someone else, the part generally doesn't load or it has trouble loading those features. So it is really bad practice to have these errors. The thing is though, we can simply use the fact that it's parametric CAD to our advantage, because we can go in, tell the computer that no, the slot is no longer 3mm offset, this feature that doesn't exist anymore. We can instead tell it that this feature is 18mm offset from the center. Solidworks will then say, yep, that part now works, and the error message will go away. 3D modeling, on the other hand, doesn't have a design tree or design history, so it's not very easy to go in and recall and change dimensions. In a sense, it's like this bowl of chili. I can go in and change the dimension of it, but once it's changed, I can't go in and simply recall it. And that's why I find it quite painful, because I'm not very good at 3D modeling, so I normally have a lot of save files because I can't simply go back and recall dimensions. And it's also painful because I put a lot of chili powder in here. Now once we're happy with our parts, we can simply get all of them and assemble them in one document to check the overall design and make sure that it looks right and that everything fits together the way that it should do. What I have here is a very basic assembly, but when you're doing proper design work, they can be hundreds of parts big with bolts and gears if you need it to be. And from there we can save it as an STL file or maybe an IGS file to export it to a CNC or 3D print it. Or if we're going to do the manual route, we can simply make a 2D CAD drawing and list out the dimensions. Although doing that would probably warrant its own separate video. The other big advantage of Solidworks is being able to test parts virtually to make sure that they won't break under expected loads. Solidworks has a pretty solid FEA simulator, as does CATIA and Fusion 360, but something like FreeCAD does lack that feature. So for a very basic test, you assign your part and material from the library, you tell Solidworks what the expected load is, where the load is coming from, and where the fixtures are. Again, this probably requires its own video, and they can be as complicated or as basic as you want them to be. I normally keep them as simple as possible, but they can provide you with a lot of good information. I used this a few times when I was designing the fly press project, just to make sure nothing would break under 5 or 10 tons of force. Although I should quickly point out that all of the deformation here is exaggerated, and it never gets close to the yield strength of the material which I chose, which in this case was 1020 steel. Now normally when I show Solidworks on the channel, I'm usually doing it in terms of doing very basic planning, very basic models and very basic parts, just to help me choose the spacing and sizes of parts and stock that I need to buy. I'm never going to be sending these parts to anyone else, so the design doesn't have to be all that complicated. Overall though, Solidworks is a really good piece of kit, but even for me, I think Fusion would probably be more than enough for what I normally need. I do recommend that you do learn it. I think it's definitely a worthwhile skill to have, and it certainly does help you plan out complex builds. And apart from that, I hope you enjoyed this video, hope you found it interesting, see you next week. That's why I find it a bit difficult, because you can't recall dimension. Took about 10 takes to do that chili scene, because he kept wanting some, and no you can't.